2019 U values. So question 5 on the exam is always the same as our U value question. Before we even get to reading the question, you have 3 formulas that you'll always write down on the page. So your first formula, U value equals 1 divided by capital R with a little t beside it. 1 divided by the total resistance. Next one, capital K, conductivity equals 1 over small r. That means 1 divided by the resistivity. And then we have capital R, resistance, equals thickness divided by conductivity. Capital T, capital K. So before you even read the U values question, the first thing you write down is those 3 formulas. Getting to our question, so the external wall of a house built in the 1990s is of 100mm concrete block construction with the 100mm partial filled cavity as shown. Calculate the U value of the wall given the construction has the following sequence and data. So we have an external render, 16mm thick, so the plaster on the outside is 16mm thick. Concrete block outer leaf, so our block wall on the outside is 100mm thick. We have a cavity, an open space, which is 50mm thick. Next we have 50mm of polystyrene insulation. We've got a block inner leaf, 100mm, which is the exact same as the outside. And then the inside we've got 12mm of plaster that you can't see. Given all of our materials, we're going to start with a table. Alright, our table that we draw is always the same. We have a set of headings across the top: material, thickness, resistivity, conductivity and resistance. And these are all used up in the formula here. So again, thickness is T, measured in meters, always meters, that's important. Resistivity is R, conductivity capital K, resistance capital R. We need to start filling out each material that's been given to us in the question, and we'll stick in the thickness as well. So that's our first task. If I go back to the question, I have 1, 2, 3, 4, 5, 6 materials to put in, and I've got thicknesses to put in along with those. The thicknesses are in millimeters, which causes a problem. I need to convert them to meters. So when I put in my materials, the first thing I'll have to do is convert each millimeter measurement to meters, and that's divide by 1,000. So 16mm divided by 1,000, 100mm divided by 1,000, 50mm divided by 1,000, and so on. I'll do that now. I've put in each of the materials into the table. So the external render has a thickness of 0.016 meters, outer leaf has a thickness of 0.1 meters, cavity 0.05 meters, polystyrene 0.05, inner leaf 0.1 meters, and internal plaster 0.012. Going back to the question, I've now inputted all of these values into the question. Next thing I have to do is start working on the second section, the thermal data. I've got 3 different types of thermal data here. I've got resistance measurements, resistivity, and conductivity. They're all the same measurement, it's just different ways of explaining them. It's all about how quickly a material loses heat, it's just different ways of measuring them. All I do is input every single one of these into my table, and I have to count for all of them. There's 2 extra that are going to be added in when you look back to the question. So at the minute I've got 1, 2, 3, 4, 5, 6 pieces of information in, but in the question I've got 1, 2, 3, 4, 5, 6, 7, 8. So I have 2 extra pieces of information to put in here, and those 2 are resistance of the external surface. What that means is there's a thin layer of air stuck to the outside of the wall. I have to account for that, and I've got a thin layer of air on the internal surface stuck to the wall. So inside the wall there's a little bit of air, outside the wall there's a little bit of air. I have to put those values in as well. The rest of them, you'll see they drop into the table. Beside external render, I've got block work, cavity, they're all the ones I've had before. So I'm going to input each of these into the correct spot. So the first one, say for example, resistance of the external surface. I haven't accounted for that yet. I have to put that in. So external surface. The resistance is 0.048. So I come across to my resistance section. Here's resistance, 0.048. Resistivity, which is small r of the external render, 2.170. External render, resistivity, 2.170. I'll do one more. Conductivity of the external blockwork. So conductivity is 1.440. Conductivity 1.440, and we add in all the rest of the measurements the same way. I've inputted almost all the measurements now. So I had a conductivity measurement for the outer leaf, resistance for the cavity, it was a conductivity for the polystyrene, conductivity for the inner leaf, a resistivity for the internal plaster. I've already put in the external surface. The last one I need to put in is the internal surface. So this last one here, down the bottom, resistance of the internal surface is 0.122. So the internal surface, 0.122. That is all the measurements filled into the table. Next up is to work our way across the table. All the data is in. What I want to do is I want to end up with a resistance measurement for every single line of the table. Some I've got work to do, some I've no work to do. So in other words, if I look, I've already got a resistance measurement here. I don't need to do anything with these two boxes. I've got a resistance measurement here. I don't need to do anything before that. I've got a resistance measurement here, so I have nothing to do with that line. The gaps is where I have some work to do. We'll start at the top. Basically what I need is, if I've got a resistivity measurement, I need to turn the resistivity into conductivity, and then I need to figure out from that the resistance. So this is the most work I'll have to do. I've got resistivity, I need conductivity. If I look up here, our second formula, conductivity equals 1 divided by resistivity. So for me to work out conductivity, it means 1 divided by resistivity, 2.170, and we work that out on the calculator. 1 divided by 2.170 equals, so 0.460. That is my conductivity measurement. So 0.460. Now I've got a little bit more work to do, because I have to turn my conductivity into resistance. And again, capital R. I get to my third formula. Capital R, resistance equals thickness divided by conductivity. So my resistance, 0.016 divided by my conductivity, 0.460. And again, I'll do that on my calculator. 0.016 divided by 0.460 equals 0.0347. So I have 0.0347. That is my first resistant measurement marked out or figured out. The next one is a bit easier. I've already got conductivity, so I don't need to be worrying about resistivity. It's already done. All I've got to do now is figure out my resistance. Again, resistance is thickness divided by conductivity. Thickness 0.1 divided by conductivity 1.440. So 0.1 divided by 1.440. Again, do it on the calculator. 0.1 divided by 1.440 equals 0.069. That is my second resistance put in, and I'm working my way down the table. So for polystyrene, again, I've already got the conductivity. I don't need to worry about resistance. To work out my resistance here, it's thickness divided by conductivity. Same here. I don't need to worry about resistivity. So for the inner leaf, thickness divided by conductivity. Back to my internal plaster, which is the last one I'll be working out, I've got work to do because I've got resistivity. I need to turn that first to conductivity, then work out my resistance. So here I'll have to go 1 divided by resistivity to give me my conductivity. So 1 divided by 6.250. And what I need is to fill out the rest of the table. With the table filled in, so all of our resistance measurements now put in, I need to get the total resistance down here. So RT, total resistance down the bottom, I just add all of those up. And it should come to 1.9395. Now, make sure you do this at least twice, because if you get a decimal place wrong on any one of these values, it's going to throw this way off, and that's going to throw your answer way off. So add that up twice to make sure you get the same answer both times. If it's 0.005 out, so if you had something like 1.9392, that doesn't make any difference. Once it's 1.93 something, it's close enough. So we add that up fully. That is our total resistance. So that's how much resistance the wall puts up to stop the heat going out through it. I need to convert that to what's called our U value number. And again, back to our formulas that we started off with, our U value is 1 divided by resistance total. So if I come down a little bit, U value equals 1 divided by RT, which equals 1 divided by 1.9395, and we work that out in the calculator. And that comes out to be 0.515, and you can keep going by 5, but the unit is very important. It's watts per meter squared per degrees Celsius. This is the only place we have to put our unit on, and that's our final answer. So that is our U value answer. And what that means is for every meter squared of wall, 0.515 watts of energy will pass through it if there's 1 degree of difference. So what that means is if it's 19 degrees outside and 20 degrees inside, there's 1 degree of difference in the temperature. At that, 0.515 watts of energy will pass out through every meter squared of the wall. And that's part A done.